Hello everyone, welcome back to this online class. Today we are going to look at how to find the roots of equations, and in particular we are going to look at the Newton-Raphson method. So we have these questions to answer using Newton's Raphson method. First of all, in the first equation, we need to find the root of x cubed minus 3x plus 1 is equals to 0 using the method, and the root must be close to 2. In the second one, we need to solve that equation, x raised to x is equals to 5, correct 4dp. And in the third equation, we need to approximate the cube root of 10, also correct to 6 decimal places. So let's see how to work out those equations one at a time. Remember, you can write here solution. Remember the method, Newton's Raphson method, that in general, if, or simply to find, to solve f of x is equals to 0. To solve that equation, we are going to use this formula that x n plus 1 is equals to xn minus f of xn over f prime of xn. This is what we are calling the Newton's Raphson method. It is an iterative formula that will help you approximate the roots of any given equation. It can be a polynomial or it can be a nonlinear equation where n is equals to 0, 1, 2, etc. So that means you must know x naught. X naught, you must know it. If it is not given, then you must find it, because that is the starting point. Well, that's what we are calling the initial guess. So now let's answer number 1. In number 1, we are given that x cubed minus 3x plus 1 is equals to 0. So it means this is our f of x, because f of x must be equal to 0. So this is our f of x. So you can say that let f of x be equal to x cubed minus 3x plus 1. So I also need f prime of x. You can just say that therefore our f prime of x will be equal to, now when you differentiate f of x, what do you get? That will give us 3x squared minus 3. But I want to evaluate at xn. So this gives us f of xn is equals to xn cubed minus 3xn plus 1. And f prime of xn, that should give us 3xn squared minus 3. So now go back to the formula. So therefore, xn plus 1 is equals to xn minus our f of xn is xn cubed minus 3xn plus 1. This you are dividing by 3xn squared minus 3. Now in this case, we are asked to find the root near 2. So the 2 there will be our x naught. 2 will be our x naught. So you can write here, comma. Of course, for n is equals to 0, 1, 2, etc. And in this case, our x naught is equals to 2. That's the starting value for the initial guess. But what about if you're not given x naught? How can you find it? If I just told to solve the equation using Newton's Raphson method, maybe correct to 5 dB, and you don't know where to start from. If that is the case, then this is what you're going to do. You can write a note. If x0 is not given, if x0 is not given, then how do we do? Or simply, what do we need to do? You are going to find, or simply the interval where f of x changes signs. Remember that our f of x is equals to x cubed minus 3x plus 1. Now, if you look at this polynomial, if I put x is equals to 0, I'm going to get 0 cubed minus 3 times 0 plus 1. I'm going to get 1. If I put x is equals to 1, f of 1 will be 1 cubed, which is 1 minus 3 plus 1, and that is negative 1. Now, look at our f of 0. The value is positive. I'm interested in the sign. And our f of 1, the value is negative. So what does it mean? This simply means that f of x changes signs between 0 and 1. So it means our root exists between 0 and 1. 0 is this and 1 is this. F of x changes signs between 0 and 1. So there's a root that exists between 0 and 1. You could also proceed to find f of 2. What about f of 2? This is equals to 2 cubed is 8 minus 6, then plus 1. That's 9 minus 6, that is 3. Now, between f of 1 and f of 2, the sign again changes. Look at the sign here. Now it is positive. So that tells you that another root exists between 2 and 1. So we are going to write, we start with the 1 and 2. There's another root between 1 and 2. And if you proceed, you'll find there's a third root, because this is a cubic equation. It must have 3 roots. So our interest is to find the root that exists between 1 and 2. So any of them can be x0. You can pick x0 to be 1, or x0 is 2. If you are going to find the root between 0 and 1, you could use x0 is 0 or x0 is 1. Any of them will work for you. So our focus is to find the root between 1 and 2. Now let's see how to proceed with the iterations. I've now explained how to find x0. So let's go back here. If I put n is equals to 1, we are going to get not 1 but 0. We are starting from 0. If n is 0, we are going to get x1 is equals to x0 minus x0 cubed minus 3x0 plus 1 over 3x0 squared minus 3. And remember, you know the value of x0. So press this in your calculator. That should give you 1.6667. When n is equals to 1, what are we going to get? It will give us x2 is equals to x1 minus x1 cubed minus 3x1 plus 1 over 3x1 squared minus 3. So we use the value of x1 that we already have, replace it, and then press in your calculator. That will give you x2 is 1.5486. So remember, we do this until we achieve convergence. When you get to a constant figure, you stop there. So when n is 2, what are we going to get? it will be x3 is equals to x2 minus x2 cubed minus 3x2 plus 1 over 3x2 squared minus 3. The same value of x2 that we have, you're going to get 1.5325. We proceed when n is equals to 3. That will give us x4. x4 is equals to x3 minus x3 cubed minus 3x3 plus 1 over 3x3 squared minus 3. Again, press. That should give you 1.53209. If I use n is equals to 4, that will give us x5 is equals to x4 minus x4 cubed minus 3x4 plus 1 over 3x4 squared minus 3. Press that, you get 1.5320. Now, what do you realize? That the value of x4 is the same as the value of x5. So it means even if you proceed to x6, x7, etc., you're going to get the same value as 1.53209, correct to 5 decimal places. So therefore, that the root near to is x is equals to 1.53209. So that is the root that exists in the interval 1, 2. Remember, if you are supposed to find all the roots, there's another one between 0 and 1, and if you proceed, there's a third root. So we have found the first root. The second root, you could pick, let's say here, you could use, maybe say, let x naught be equal to 0, or somebody can use 1. You are still going to get the same answer. What will differ is the number of iterations. And you proceed with the same procedure of the Newton-Raphson method. Now, let's answer question 2. We are through with question 1. This is done. Look at question 2. We need to solve x raised to x is equals to 5 using the Newton-Raphson method, correct to 4 decimal places. So this is what you need to do in part 2. You will write number 2. We solve x raised to x is equals to 5. So this can as well be written as, if I take log on both sides, or simply natural log on both sides, I am going to get that ln x raised to x is equals to ln 5. And remember, ln x raised to x is the same as x ln x. That is equals to ln 5. If I take everything to the left-hand side, so from here we'll get x ln x minus ln 5 should give us 0. So, and in general, f of x must be equal to 0. So this will be our f of x. This is our f of x. You only need to know your f of x and the starting point. In this case, we can just say that let f of x be equal to x ln x minus ln 5. So from here, that means, therefore, our f prime of x, if I differentiate, I'm going to use product rule here. Differentiate x, keeping ln x constant. When you differentiate x, it is 1. Then plus now keep x constant, differentiate ln x, which is 1 over x. The ln of 5 is a constant. When you differentiate, you get 0. So this should give us ln x plus 1. Now simply you can write ln x, then you add to 1. Now, what is the iterative formula? From here, we can be able to get f of xn to be equal to xn ln of xn minus ln 5. And this other one will give us f prime of xn. That should give us ln of xn plus 1. So therefore, we expect that xn plus 1 must be equal to xn minus xn times ln of xn minus ln 5. Everything over ln of xn plus 1. Remember, you work out this separately. But what about x naught? Remember here, n is equals to 0, 1, 2, etc. So the question is, how do we find x naught? Because in this case, you have not been given x naught. So to find x naught, this is what you're going to do. We are going to investigate the sign of f of x and check where f of x changes signs. So you can write, to find x naught, comma, investigate the interval, or simply investigate the interval where f of x changes signs. F of x changes signs. So you are going to work out this. Let's say we start with f of 0. Can 0 work? We don't have ln 0, so I can't start with 0 because that will give us infinity. Let's start with 1. F of 1 will be equal to 1 times ln 1 minus ln 5. And so when I press this in my calculator, I'm going to get f of 1 to be negative 1.6. I just need the signs. I don't need to write so many numbers. And the sign here is negative. Let's try with f of 2. That will be 2 ln 2 minus ln 5. Press that in your calculator. You need to get f of 2 is equals to negative 0.2. Again, the sign is negative. What about if we go to f of 3? I'll have 3 ln 3 minus ln 5. If I press that in my calculator, I am getting 1.68. That's positive 1.68 something. I don't need to write all the numbers because I'm just interested with the sign. So you need to check, where does f of x change signs? I can see there's a change of sign because from negative we go to positive. So the interval is when x is 2 and when x is 3. So this means that f of x changes signs in the interval 2 to 3. So that means there's a root that exists between x is equals to 2 and x is equals to 3. Now, you can pick x naught is equals to 2, or you can use x naught is equals to 3, any of them. And in this case, let's use our x naught to be 2. So you can say, let x naught is equals to 2. Somebody can use 3, or any value between that interval. Now, let's perform the iterations. We start with when n is 0. We put n is equals to 0. What are we going to get? Look at our iterative formula, it is this one. That will give us x1 is equals to x naught minus x naught ln x naught minus ln 5. This is over ln x naught. Add this to 1. That should be in bracket. Let us press this in our calculator. What are we going to get? So when you press that, remember x naught is 2, you need to get x1 is equals to 2.1318. 2.1318. Proceed with the iterations. Find x2. So when I put n is equals to 1, what am I going to get? I'm going to get x2 is equals to x1. Already we have found x1 minus x1 ln of x1 minus ln of 5. Everything over ln of x1 plus 1. Again, press this in your calculator. You need to get 2.1294. 2.1294. Remember, you proceed until you get to a constant figure. Let's try when n is 2. N is equals to 2. What are we going to get? That will give us x3 is equals to x2 minus x2 ln of x2 minus ln 5. And the whole of this is divided by ln of x2 plus 1. When I press this again, I'm going to get 2.1294. So we realize that the value we get as our x2 is the same as the value we get as our x3. So we stop there and say that because this value is the same as this, therefore our x is approximately equal to 2.1294. That is correct to 4 decimal places. So that is the root of that equation. Remember, we are solving x raised to x is equals to 5. So it means x must be 2.1294 approximately. The last question. is part 3. Let me take you up. So we are done with number 1. We are also done with number 2. Let's work out number 3. We need to approximate the cube root of 10 using the Newton's method, correct to 6 dp. And here you are asked to take x naught is equals to 2. If you're not given, you can also be able to find x naught by investigating the signs of f of x. So let's work it out. Cube root of 10. How do you, we know we can press that in the calculator, but how do you apply this technique to approximate that value? So you could write number 3 here, and here we need to approximate the cube root of 10. So what you're going to say is that let x be equal to the cube root of 10. So you say let x be equal to the cube root of 10. That is cube root. So if I cube both sides, what will I get? So this means that when you cube both sides, x cubed will be equal to 10. That's what it means. Or if I take everything to the left-hand side, I'm going to get x cubed minus 10 is equals to 0. So the left-hand side of this equation is our f of x. This will be our f of x. Remember, f of x must be equal to 0. So we'll say here let f of x be equal to x cubed minus 10. So therefore, our f prime of x is the same as 3x squared. Let us evaluate this at x is equals to xn. So write f of xn is the same as xn cubed minus 10. And this other one is f prime of xn. That will give us 3xn squared. And so the iterative formula is that xn plus 1 is equals to, remember that xn plus 1 is equals to xn minus f of xn, which is xn cubed minus 10 divided by f prime of xn, that is 3xn squared. For this case, our n is equals to 0, 1, 2, etc. But the question is, what is x naught? The starting point. We are told to start with the 2. But even if you're not given x naught is equals to 2, you could also find it this way. Just write when x naught is not given, when x naught is not given, we need to investigate the sign of f of x. Let's see. What is f of 0? That is 0 cubed minus 10. That's negative 10. The sign there is negative. What about f of 1? That is 1 cubed minus 10. Negative 9. Again, the sign is negative. Let's try f of 2. 2 cubed minus 10. That is 8 minus 10. And that is negative 2. Again, the sign is negative. You proceed until you get where the sign changes. I could try f of 3. 3 cubed, that is 27, minus 10. That should give us 17. Now it is positive. So there's a change of sign between x is 2 and when x is 3. So it means the root exists in the interval 2 to 3. Now, that's why we are saying start with x naught is 2. You could say let x naught be equal to 2, or somebody could use x naught is equals to 3. You'll still get to the same value. So for our case, let us use 2 as our x naught. So when you put n is 1, not 1 but 0, put n is equals to 0. Now we are performing the iterations. What are we going to get as our x1? So with this, you're going to get x1 is equals to x naught minus x naught cubed minus 10 over 3x naught squared. Press this in a calculator. Where there is x naught, you need to put 2. What are we going to get? So with x naught is equals to 2, you need to get x1 is equals to 2.166667. So write it 2.166667. That's correct to 6 dp. What about when n is equals to 1? So you can put n is equals to 1. That means you are going to get x2. So our x2 will be equal to x1 minus x1 cubed minus 10, everything over 3x1 squared. When you press again in your calculator, you need to get 2.154504. 154,504. Let's proceed with the iterations until you get to a constant figure. Let's put n is equal to 2. That will give us x3. x3 is equal to x2 minus x2 cubed minus 10 over 3x2 squared. This should be 2.154435. We can try another one because up to there the solution has not converged. Let us put n is equals to 3. Here we are going now to get x4 being equal to x3 minus x3 cubed minus 10 over 3 times x3 squared. When you press this in your calculator, you need to get 2.15435. So if you look at the value at x3 and x4, they are the same. So it means even if I proceed with x5, x6, etc., I'm going to get the same value. So it means our iterative formula has converged to a common value, which is 2.154435. So therefore, that is our answer. That's the value of x. So therefore, x is equals to 2.15443. And what was x? X here, we said let x be the cube root of 10. So it means the cube root of 10 is approximately equal to 2.154435 by Newton-Raphson method. Remember, this is correct to 6 decimal places. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we'll look at more problems involving finding the roots of equations. Bye-bye.